Good morning. Welcome to Algebra 2. This is lesson 9.6. We're going to solve rational equations. These are equations in the form of a ratio or a rational function equal to a rational function, maybe more than one rational function. We get a new code for today. That code is CM for cross multiply. And so let's try that out. Let's try out the new code. CM for cross multiply. And here we go. To cross multiply, and this is something that I was in on a discussion back when I taught in the public schools. A teacher said, I don't use the phrase cross multiply. That cross thing is like, it's a school where there are a lot of Jewish students, and the idea of cross said, well, I'm concerned my students are going to take that as a symbol of Christianity. And so she said, no, I don't want to use that phrase cross multiply. So I said, well, okay. I'm still going to use the phrase cross multiply in my class, but as a teacher, she opted to not use the phrase cross multiply. That's fine. But hopefully that'll be no problem whatsoever around here to use the phrase cross multiply. Now, when you cross multiply, you can take the product of the extremes and set it equal to the product of the means. These are the extremes. Those are the means in standard mathematical terminology. I'm going to set it up so that the variables, in this case, the means, product of the means, are on the left. I like keeping the variables on the left. So this diagonal, x minus 1 times x plus 4, is going to be equal to the product of the other diagonal, which is 6. Now, here's the idea. A lot of students get tripped up on when to cross multiply. Sometimes we get similar problems where cross multiplication should not happen. Have you ever been in a situation where you had to multiply 2 over x minus 1 times x plus 4 over 3, and you got confused and you thought that when you're multiplying fractions, it's time to cross multiply? When in fact, no, this is not where cross multiplication should be happening. This should just be 2 times x plus 4 over 3 times x minus 1. As a math educator, I've seen it. I've seen it where students are asked to multiply fractions and they get confused and they think, oh, let's cross multiply here. No, we don't cross multiply there, but we do cross multiply when you have a fraction equal to a fraction. So cross multiplication in this case is going to be followed up by the FOIL method. So would you now proceed to use the FOIL method on the left-hand side? When you're done, take a peek up here, see if we agree on the outcome of using the FOIL method. So mine came out to x squared plus 3x minus 4 equals 6. Any questions on that? What's the next code going to be? Yeah, if you subtract 6 from both sides, then we get what we often are looking for, and that is a 0 on one side. So when you subtract 6 from both sides, combining like terms on the fly, we get x squared plus 3x minus 10 is equal to 0. Now, what, and if you think you know the answer to this, please raise your hand. What do you think the next code is going to be? Yeah, the factoring code is the letter F. So class, go ahead. I'm going to tour the room to see what factorization you come up with. Factoring. It's still happening, even though it's the month of May. The students who are using codes on homework tests and quizzes are the ones who are shining like stars in the grade book. It just happens unit after unit. For some reason, I think I know the reason, it's because students are verbally engaged. When you're using the codes, that's a sign that your words are turned on in your mind. You're using your words, as was the phrase uttered in chapel just weeks ago. Use your words. Use your codes. Use your codes. So anyway, I'm thinking, what is it? Does someone have the correct factorization? Alana, go ahead.
So x minus 2
Yeah, that does it. X minus 2, x plus 5. So now we're all set up. We have a product equal to 0. So when we have a product equal to 0, we use the zero product property. Finish it from here. Or x plus 5 equals 0. And finishing strong, we add 2, subtract 5 to get a solution set of x is an element of the set 2, negative 5. I wonder if both of those values actually make it true. Well, we know we can't let x equal positive 2, or rather positive 1, because that would cause division by 0 up here. So there is a restriction going into this. X cannot equal 1, but we didn't get x equals 1. We just got 2 and negative 5, so we're good to go. Both of those do make it true upon checking. The homework does ask you to check your answers. And so in the homework solutions, you'll see I checked every answer. And there's a surprise in the homework that's due tomorrow. One of the answers that shows up in the algebraic work actually results in division by 0. So I would just systematically check every time to make sure it's true. And by check, I'm not going to require that you take notes on this right now. But what I mean by check is to check x equals 2. Here's how it's going to look in the solutions. Is x really equal to 2? Well, 2 over 2 minus 1, is that equal to 2 plus 4 over 3? It's just a matter of saying that 2 over 1 is 2, and 6 over 3 is also 2, check. I mean, it's just little bits of arithmetic like this are involved in checking. But I would like you to apply cross multiplication in example 2. And I'm just going to pause the camera for a second while you work on example 2. We're back. We're not live. We're not live streaming, but we're back. What did you get for the cross multiplication line? Help me out, please. Is there a volunteer who's willing to give me your line of algebra lined up with C? Okay, Bethany, go ahead.
8x equals 5x plus 15.
Okay, now 8x equals 5x plus 15 is good. I'm going to leave it undistributed because, just for clarity, I mean, you're certainly fine. You'll get full credit if you do it, Bethany did just right, 5x plus 15. But you could separate that into 2 steps with distribution. At that point, we're going to subtract 5x, codes in green, algebra in blue. So dividing by 5 should give us 5, and it does check out. So any questions on how to get x equals 5? In set notation, by the way, that would be x is an element of the set 5. Last call for questions on example 2. Right now, let's go to page 3, or to example 3. This time, cross multiplication is not our first move. Now, there's a couple of different approaches to this. Sometimes students will just doctor up the fraction so that you can get fraction equal fraction. Then cross multiplication would be okay. But there's a shortcut to that. It's a little more challenging. But I'd like to teach you this shortcut. It's a challenging shortcut called multiply both sides by the LCD. Of course, we still say this is OE, the original equation. So please put our standard start code there. But we're going to multiply both sides by the LCD, which I'd like to argue is 6x. We're going to multiply both sides by 6x. Now, I realize that it may not be obvious to you why the lowest common denominator is 6x. Is there anyone who'd like me to explain it? Yeah, okay, so I do have some requests for explanation. Here's the process that's going on in my mind. I don't expect you to write this down. But if you were doctoring up this problem, big if there, but if you were going to use the doctoring approach, which we are not, we would multiply the first fraction by 1 in the form 3 over 3, and the second fraction by 1 in the form 2 over 2. Wouldn't that give us a common denominator of 6x? You see, the lowest common denominator, LCD, is the LCM, the lowest common multiple of the denominators. And so the lowest common multiple of all the prime factorizations in the denominator would end up giving us a 6x. So that's the thinking process that you end up going through, which results in a 6x on the left. Please write 6x times the quantity 3 over 2x minus 5 over 3x. Correct my ratio there, 3 over 2x minus 5 over 3x, and also multiply the right-hand side by 6x, which opens up an opportunity to draw the two arrows of distribution. 6x will be distributed to both terms in parentheses. And here's my challenge for you. My challenge is to cancel on the fly. So if you were to distribute 6x, which can be thought of as 6x over 1, if you were to distribute 6x to this fraction, what would cancel? Feel free to call it out. Yeah, the 6 and 2 would reduce. I'm essentially asking you to do some mental math here. This fraction times that fraction, what would be, I mean, yeah, you can reduce the numbers, but what would cancel in that multiplication? Owen, what would cancel? Actually, the x's would cancel. That's what you need to see. When you multiply this fraction by that fraction, the x's cancel, leaving you with what numbers? Raise your hand if you think you see the numbers that would result from the first arrow of distribution. Lauren? Would it be what? I'm sorry?
Would it be 9?
It would be 9 because 18 over 2 is 9. That's what it would be. That's the first arrow of distribution. On the first arrow, the x's cancel, and you get 18 over 2 is 9. Minus, now what would the second arrow of distribution give you? Let's go with Anna this time. Anna?
Negative 10. Or minus 10.
Yeah, minus 10, because on the second arrow of distribution, the x is back now. So 6x times this fraction, the x's cancel. You can think of it as 30 divided by 3, or just plain 10. So that's the result of distributing 6x across the binomial. Now we're almost there. We just simplify that to get negative 1 is 12x, and divide by 12 to get x is negative 1/12. Coding along the way is simplify and d12. Does anyone have any questions on how to get x equals negative 1/12? Yes?
Wait, so why do we multiply by 6x?
Well, the nice thing about multiplying both sides by the lowest common denominator is that it'll clear fractions every time. You have a problem that starts with fractions, but once you multiply by the lowest common denominator, it's guaranteed that all the fractions will clear. And you'll get a much cleaner equation. That's really what we're going for, is clearing fractions. So when you have an equation that has fractions in it, you want to clear fractions by multiplying both sides by the LCD. That's the big idea for this last lesson. If you have one fraction equal to one fraction, then cross multiply. But if it's more than one fraction equal to a rational number, then multiply both sides by the LCD. By the way, restrictions on this are x cannot equal 0 because of the x's in the denominators up top. But our answer didn't come out to be 0, it came out to negative 1/12, so we're good to go. So let's talk about our new strategy, which we can't use cross multiplication here because it's not a single fraction equal to a single fraction. Instead, we're going to use the strategy of multiply both sides by the LCD. So who would like to tell me what you anticipate the LCD would be if we were to engage in that doctoring up process? If we were to doctor these up so that they all had the same denominator, what would that common denominator be? Please raise your hand if you see what that would be. Okay, yes, go ahead.
6x.
Raise your hand if you agree with an LCD of 6x. Thanks, you can put your hands on. Raise your hand if it's not clear to you what's going on there. It's like, where did she get 6x? Is there anyone who's unclear, uncertain on that? Okay, so here's the idea. you've got to ask yourself, since an LCD is the LCM of the denominators, I mean, let's take a look at, well, first of all, they would all need an X. We'd have to doctor it up so they all have an X. So as far as the numbers go, the multiples of 2 are 2, 4, 6, 8, etc. The multiples of 3 are 3, 6, 9, 12, dot, dot, dot. The multiples of 6 are 6, 12, 18, dot, dot, dot. So the lowest common multiple, the lowest number that's common to all of those lists of multiples is in fact 6. So the lowest common denominator, or at least the numerical portion of it, is going to be the lowest common multiple of all of the denominators. So that's where the 6 comes from. You can see it. I mean, 2, 3, and 6. Sometimes it's just a matter of multiplying, 2 times 3 to get 6, but it doesn't always work. How about like with 6 and 8? If you want to find the lowest common multiple of 6 and 8, it's not 48. It's not a matter of just multiplying them together. Think about it. In your mind, when you think of the multiples of 6 and the multiples of 8, what's the lowest common multiple of 6 and 8? So just pause for a second. So some of you are writing, you're going ahead doing something else, but go ahead and put your pencils down. Pause, put your pencils down. What is the lowest common multiple of 6 and 8? Hint, it's not 48. What is it? Class?
24.
I'm sorry? 24 is correct. So really what you're doing here is you're looking at the lowest common multiple of the numbers in the denominator. But you also have to account for the variable. So 6x. Class, let's take a look then at what the effect of multiplying both sides by the lowest common multiple is. So after OE, we're going to multiply both sides by the lowest common denominator. By the way, restriction x cannot equal 0. Okay, so here we go. I'm going to randomly call on you to help me out. When I multiply both the left and the right by the lowest common denominator, I have to distribute. It's a 5, by the way. Those of you wondering, what is that? Is that the whip and nay nay? No, it's a 5. You gotta get your terminology correct here. So, let's distribute. There's 2 distributions that need to occur. One's on the left, one's on the right. So when you distribute the 6x using both arrows of distribution, what do you get on the first arrow of distribution? Please, let's go with Amani. First arrow. What is the first arrow of distribution? Now, Imani said 15. It kind of makes sense because the x's cancel. We get 30 over 2, which is 15. See, it worked. We're clearing out the fractions. What is the second arrow of distribution over here on the left? Help me out with that, please. Daniel.
12x divided by 3, so that's 4x.
You got minus 4x. Good job. Any questions on distribution on the left? Raise your hand if you got 15 minus 4x when you did it. Just want to see where we're at in terms of understanding that. Okay. Gerald, would you tell me over here on the right, when I do the 2 arrows of distribution, what do you get for the first arrow of distribution?
6.
Yeah, 6x times 1 over x. The x's cancel to get 6. Mason, would you tell me what you get for the second arrow of distribution? First of all, tell me this. When you multiply 6x by 5 over 6, what cancels? Actually, the 6's cancel. 6x times 5 over 6, the 6's will cancel, leaving you with what?
5x.
With 5x, that's it. That's all there is to it. That's how you distribute. When you're distributing, expect things to cancel. That's why we're multiplying by the LCD, is so that things will cancel. If you do it right, there won't be any fractions left on the line that contains, that results from multiplying both sides by 6x and distributing. So it's gonna happen every time. If you're doing things right, once you get to the distribution line, fractions will be gone. Now, it's pretty straightforward. I'm gonna subtract 5x and subtract 15 in one fell swoop to get negative 9x equals negative 9, and dividing by 9 gives me x equals 1. Any questions on example 4?
Do we have to do x to the L?
I'm sorry, what's that?
Never mind.
Yeah, well, if you do set notation, it would look like this. X is an element of the set 1. Further questions? All right, let's go to our last page. Examples 5 and 6. Okay, here we go. Now, I'd like you to fill in the LCD box right up here. What is the lowest common denominator of all the fractions over here? I almost said the infractions, but I would like you to survey all the fractions, take inventory of all the fractions. What is the lowest common denominator? Help me out with that, please. Thomas. Not Thomas, but Thomas. Thomas Gonzalez, yeah. What is the lowest common denominator? Does this seem kind of confusing?
Yeah.
Okay, if this were a 4 and that were a 5, the lowest common denominator would be 4 times 5 or 20, right? But this is an x plus 1, that's an x minus 2, so the lowest common denominator, you just multiply them together, it's going to be x minus 1 times x minus 2. That's all there is to it. Okay? So fill that into the LCD box. So that means we are going to multiply both sides by the lowest common denominator, x minus 1 times x minus 2. So it's a good thing we have a lot of space, because when we multiply by x minus 1, friends, it's x plus 1. X plus 1 times x minus 2. So x plus 1 times x minus 2. Please use square brackets. Use a big square bracket to house x over x plus 1 plus x over x minus 2 equals, and then on the right, we also multiply by x plus 1 times x minus 2. So that's just multiplying both sides there. We are going to concentrate hard on the 2 arrows of distribution. Each arrow is going to produce a cancellation. On the first arrow of distribution, Owen, can you tell me what cancels on the first arrow?
First arrow, x plus 1 gets canceled.
That's correct. The x plus 1s fall out on the first arrow of distribution, leaving you, Owen, with what 2 factors?
X and x.
No.
Or
It's x and x minus 2.
x.
Because on the first arrow of distribution, when the x plus 1s drop out, all that's left is the x and the x minus 2. Okay, Thomas Kelch. On the second arrow of distribution, what cancels?
X minus.
No, this is Thomas Kelch. No, if you take this and multiply it by this fraction, there's a cancellation. What factors cancel? Okay, here's what you should be visualizing. You need to get this. This is scratch work. I'm going to put it over here on the side. The second arrow of distribution is taking the x plus 1 times x minus 2 and multiplying it by x over x minus 2. Now look at all the factors upstairs and downstairs and tell me, Thomas, are there any common factors? Yeah, the x minus 2's cancel. This is what I'm asking you to see with your mathematical imagination. When you look at the second arrow of distribution, I would expect you to see the x minus 2's canceling. Do you see that now? What remains after the cancellation process?
Just
X and what?
2x.
No. So you're taking this times this And after the x minus 2's cancel, what remains?
Just X.
Oh wait, take a look at everything in this red oval and this green oval. When the x minus 2's are gone, what's left?
X times X plus
Yes. Yeah, that's what you need to see. So I copied down the plus, x times x plus 1. Then on the right, I'm just going to use the FOIL method. By the way, this is all under the code distribution. So it's going to be x squared minus x minus 2. So I distributed and used FOIL all at once. Okay, class, this is the heart of the lesson. You've got to be able to distribute and cancel on the fly. Thomas, did that help? You see now what's going on? Okay, so now we're going to distribute again. This is not unusual in the homework to have double distribution. We distributed the red to each of these green circles here. So red to the first green. In fact, Thomas, can you remind me what canceled when I distributed red to the first green circle?
the X plus 1.
Yeah, the x plus 1's canceled. So do you see now why it is that x times x minus 2 was the result of that first arrow of distribution? And then the second arrow of distribution, things canceled out, leaving us only with the x and the x plus 1. Now we have to distribute again. And our second round of distribution gives us x squared minus 2x plus x squared plus x equals 2x squared minus 2x minus 4. That's less complicated because there's no fractions involved. Now, it may look complicated, but we're actually just one step away. Because notice that if you subtract 2x squared from both sides, and if you add 2x, everything goes away, except for x equals negative 4. So there's so many cancellations that occur that x equals negative 4 is the next and final line. Do you have any questions on how to get x equals negative 4 on example 5? Yeah, it's clear to me now that the place where you need help and practice, is on the arrows of distribution. So we're going to practice that a little bit. Last call for questions on how to get x equals negative 4. Okay, now, people who go on to example 6, and please don't, there's a new concept in here that throws people off. So do not proceed to example 6. Let's stay together on this. There's something new here, and the new thing is F star. You've never done an F star before. Today's the first time in your life doing green F with a red star. And here's the story. It's a new twist in algebra. And to help you see what the star is about, and, oh, Thomas, go ahead.
Would we have to use this method on the test, or could we use, what's the other method for?
You mean the doctoring method on the previous
Yeah.
problem? Well, before I answer that question, I want to make sure you master the method that we're learning today. Because, yeah, sometimes people are saying, wait, I don't want to learn this, it's too challenging. Well, let's learn it. You can all do it. In fact, when you were doing that double arrow of cancellation, or that double arrow of distribution, I saw that you could get it. We just need practice. So, but first of all, the F star is a new thing. F stands for factor. And notice that when you factor the denominator, well, go ahead and factor the denominator. Factor x squared minus x minus 12. And then after you factor, just pause and look up here. All of you should be factoring x squared minus x minus 12. Let's see how to do with that. All right. Lauren, you're on. Please tell me what your factorization is for x squared minus x minus 12.
This is x. X minus 3.
Did you say x minus 3? Okay.
And x plus 4.
Yeah, x minus 3 times x plus 4. When you do outers plus inners, you get positive x. So you need to make an adjustment on this. That's not quite correct. You did a good job of coming up with two numbers that multiply to -12. -3 times 4 is -12, but 4x plus -3x, outers plus inners, does not match up with that.
Oh, so it's positive.
That's right, so it's gonna be +3 and -4. Now, we have a problem that's solved with the star, the red star. Here it is. We have an x minus 4, but that's a 4 minus x. So you need to make an adjustment. Here's the adjustment, which is that to which the asterisk refers. Instead of 4 minus x, I'm gonna write x minus 4, which is a doctoring up of the problem. It's a change in the problem that can be counterbalanced by putting a negative sign right there. So what I'm arguing here, just want to point something out. I'm arguing that 4 minus x is the same thing as x minus 4 multiplied by -1. And I'm just gonna, on a blank sheet here, is it really true that I'm allowed to replace 4 minus x with x minus 4 as long as I make it negative? Well, look at this. When you distribute the -1, you get 4 minus x. So every time you see a 4 minus x, you can replace it with x minus 4 as long as you multiply it by -1. And that's what the red star is referring to. It's like, it's a little bit of a change. I mean, think about it. So, notice how Lauren got an x minus 4 over here? So we're really cheering and rooting for an x minus 4 appearing on the left-hand side also. That'll make our calculation of the lowest common denominator much less complicated. But it's a little bit off. It's not x minus 4, it's 4 minus x. You can always change the order on subtraction as long as you counterbalance it with a factor of -1. And that's exactly what we do. Yes, question?
And then why did you put 2 over x?
Oh yeah, so that's a, well, you've heard of a typo. This is a rito. That change was unintentional. So, yeah, I should have just copied down the x plus 3. Further questions on that? Okay, now, what is the LCD going to be in this case? Help me out, please. Let's go with Mia. What is the LCD in this case?
Is it for like all 3 of them?
It's got to be for all 3 of them.
X plus 12.
Actually, you're making it a little too complicated because it's like, think of this as if this were like a 3 and that's a -4 and this is a 3 times -4. If you were to think of it that way, it's like, well, or you could think of it like this. If this were something over 3, this were something over 4, this were something over 12, the lowest common multiple of these 3 numbers is just 12, right? So that's with numbers. Now we have letters that represent numbers. What do you think the lowest common denominator is going to be here?
X plus 3. X minus 4.
Yep, that'll do it. That's the lowest common denominator. So it's the expression by which we are going to multiply both sides. So here we go. This is the main idea of today, is learning how to solve rational equations by multiplying both sides by the lowest common denominator. That's how we clear fractions. So get ready for distributing x plus 3 times x minus 4 across. And by the way, on the right-hand side, it's kind of nice because you know it's just going to be 2. I mean, come on. When you multiply this by that, everything cancels except for the number 2. So all we have to really write down here is 2 over x plus 3 plus, because minus negative is plus 3 over x minus 4. Okay, this is going to be sweet because cancellations will occur when we multiply red to green, and the green looks a little reddish today, but oh, never mind. So distributing red to the first green produces a cancellation. Here's the second arrow of distribution. So here we go. Is there a volunteer who'd like to tell me, after things cancel out, what's left when I multiply red by the first green one there? Okay, Lauren?
2x minus
Yeah, I'm gonna write as 2 times x minus 4, then we'll distribute on the next line, but your answer is correct. Okay, plus, and now, curious, how many of you got that on the first arrow of distribution when you were doing it by yourself? Some of you just, hold back there, okay? All right, Jay, would you tell me what the second arrow of distribution is?
Would it be 3x plus 9?
Yeah, 3 times the quantity x plus 3 will be 3x plus 9, so that's equal to 2. So the code for this is distribute. Yes? Right here? Your question is that supposed to be negative? No, because we have minus, negative is plus. That's what the star was all about. It's a new concept. If you change 4 minus x to x minus 4, you can do that as long as you also multiply by negative 1, which I just multiplied upstairs on the fraction. So that's a new concept, signified by f stars. So from here, you should be able to finish it, solve from here to the end, see what the final answer is. It's like 5x. I'm getting 1 over 5. Are you getting 1/5? All right, we're in good shape. So the homework is due tomorrow.